Suppose the number of customers arriving at a library follows a Poisson distribution with an average of lambda customers per unit of time. In other words, if y is the number of customers arriving in the interval between 0 and t, then y follows a Poisson distribution with the parameter lambda t. Suppose that the library opens at time t equals 0. Let x be the time that the first customer arrives. Prove that x follows an exponential distribution with the parameter lambda. First, let's compute the probability x is greater than t, and this is equal to the probability no arrival of any customer in the interval 0 and t. Why this is true? If this is 0, t, and this is the first customer arrival time, which is x. Now, if x is greater than t, so x is here, that means there must be no customer between 0 and t. So that means if x is greater than t, then this must be true. So there must be no arrival between 0 and t. And conversely, if there's no arrival in 0 and t, so if there's no customer here, that means the first customer must be after t, right? So in other words, if this is true, x must be greater than t. So we just showed that these two events are equivalent, right? So this is also equal to the probability y is equal to 0. And recall, y is the number of customers arriving in the interval between 0 and t. So if there's no arrival in between 0 and t, so that means the number of customers between 0 and t is 0, right? So now recall, y follows a Poisson distribution with the parameter lambda t. So this is equal to lambda t to the power of 0 divided by 0 factorial e to the negative lambda t. This is just a definition of a Poisson distribution. And this is equal to e to the negative lambda t, because these are all ones, right? So now let's compute the distribution function of x. So the distribution function for x is equal to the probability x is less than or equal to t, and this is equal to 1 minus probability x is greater than t, and this is equal to 1 minus e to the negative lambda t, because we just computed that this is e to the negative lambda t. So this is precisely the distribution function of an exponential distribution. Thank you for watching the video.